Welcome to Chapter 4, and Chapter 4 is on quadrilaterals and polygons. And so what I've done here at the beginning, I'm giving you two ways to organize all the different kinds of quadrilaterals, and you're allowed to use this on your test. So I've got, first of all, a Venn diagram, which shows inclusion. So I'm going to show you how to read this Venn diagram. Everything on it is a quadrilateral. Go ahead and point off to the side. A quadrilateral's root word is quad, which means four. So a quadrilateral is just any four-sided polygon. If it has four sides, it's a quadrilateral. So every picture on here is a quadrilateral. Now, if there's specific relationships amongst the sides and angles, we give them special names. And again, it's kind of like you can think of the big thing as, okay, we have a big group of humans, and we can divide humans into males and females. And then we can divide our males into males with brown eyes and blue eyes. And we can keep making the criteria more and more specific. And that's what this Venn diagram does. So a very common type of quadrilateral is what we call the parallelogram. And again, its root word is parallel. And a parallelogram has both pairs of opposite sides that run parallel. So go put those little markings on there. A trapezoid only has one pair of parallel sides. So again, put those markings on there, and we discussed in a previous section what those markings mean. Sorry, I had to cough. I covered up my mic there for a second. So let's go talk about specific types of parallelograms. In the purple circle, I have rectangles. Every rectangle is a parallelogram, is a quadrilateral. So the most specific name for this figure right here is a rectangle, but it is also a parallelogram, and it is also a quadrilateral. A parallelogram has, a rectangle has four right angles, and that's what makes it a rectangle. Rhombuses don't have to have right angles, but they do have to have all sides congruent. So go put those markings on there. And a square, I know this looks distorted in here. It's because I shrunk it down to fit on the screen, so it kind of made my square look like a rectangle. Sorry about that. Anyway, squares have both criteria, all sides congruent, and all the angles are 90 degrees. And again, we read this inclusively. Every square is a rectangle, a rhombus, a parallelogram, and a quadrilateral. Trapezoids, again, I told you, just have one pair of parallel sides. If the legs are congruent, then we call it isosceles. If not, then it's not an isosceles trapezoid. So let's go on the outside here. We also have some quadrilaterals that don't really have any specific criteria. But there's one other one I want to put on here. I'm going to go down here and have you write the kite. Sometimes there's questions about those, so we'll give it its own circle right here. Every kite is a quadrilateral, not a parallelogram, but a quadrilateral. And so I'm going to draw a figure that looks like a kite that you'd fly in the air. It has two pairs of consecutive congruent sides, so it looks like this. All right, and then on the next page, I've got another display of how things are related, and I've got the flow chart. With my OCD, it's kind of bugging me how these arrows are going. I believe in your note packet they're going the right way because I fixed it, but these arrows should be going up to the top like this. So if they're not doing that in your note packet, go fix it. This we're not going to worry about, and instead of the word again, I got this off the internet, we'd say trapezoid, not trapezium. So what we've got here, again, every square has four right angles, making it a rectangle, and four congruent sides, making it also a rhombus. A rhombus has four congruent sides. A rectangle has to have four right angles. And they're all parallelograms, and parallelograms have opposite sides parallel. So you read it from the bottom up. A rhombus is a parallelogram, is a quadrilateral. The kite has two sets of congruent sides that are consecutive. That means right next to each other, so it might look like that. Again, a trapezoid just has one pair of parallel sides. If the legs on it are congruent, then we call it isosceles. And then we've got a lot of properties that go with them. But first of all, we're just going to practice giving the most specific name. Yes, this is a quadrilateral right here, but it's not its most specific name. Because of its markings showing two pairs of congruent consecutive sides, we would say its most specific name is a kite. On the next one, I can see it's a parallelogram, it's a quadrilateral, but it's a parallelogram with four congruent sides. It's not showing four right angles, so I don't say it's a square, but this is what we'd call a rhombus. The next one doesn't have markings, but we do have angle measures and side measures. So I can see that the angles aren't 90 degrees, so it's not a rectangle. It's not a square, it's not a rhombus. The most specific name for this one would be a parallelogram. Parallelogram. And last one, because I've got the four right angles, but the sides aren't the same, the best for this is a rectangle. Again, if I had those right angles and all of these were marked as the same, then I could call it a square. All right, state all possible names. So go circle the word all. What is this thing? Well, let's start with the most loose name. It's a quadrilateral because it has four sides. They all get to be called quadrilaterals because they all have four sides. It's a parallelogram because I have opposite sides parallel. It's a rectangle because I have four right angles. It's a rhombus because all sides are congruent. And it's a square because it's both a rhombus and a rectangle. The most specific name is square, but it is actually all of the others. So this next one is a quadrilateral, but it's not a parallelogram because it only has one pair of parallel sides. And these legs aren't the same. So the best thing I can call this is a trapezoid. And again, you can use those charts to help you out with these. Next up. What is the most specific name for this? A rectangle, but it said to give all names. So I would call this a quadrilateral, a parallelogram, and again, just use the chart, a rectangle, and that's it. It is neither a rhombus nor a square. The next step, it says angles in quadrilaterals, and I want you to write next to this, they must add 2. And let's put a box right there, have a sum of. Because every quadrilateral is really two triangles, and we know the angles in a triangle add up to 180 degrees, well then we'd have 2 of those 180 degree interior triangles, which adds up to 360 degrees. So every quadrilateral, the angles have a sum of 360 degrees. So what I would do to find this missing angle right here, I don't really need to call it X. I can just say, well, I have the 360. I'm going to remove the 90 in the top corner. I'm going to remove the 114, and I'm going to remove the 86, and that'll leave me what's left over for question marks. So you may need a calculator for these, or if you want to just go on your Chromebook and grab an online calculator. By the way, Desmos is a really good online calculator, DSMOS. But if I do 360 minus 90 minus 114 minus 86, I have 70 degrees left for question mark. The next one up with a little algebra, solve for x, can do, because I know that in a quadrilateral, all of the angles add up to 360 degrees. So I'm going to combine like terms. I've got 86, 94, 94, and minus 2 that are all considered like terms. When I add those up, I end up getting 272 plus 11x is equal to 360. So using a little algebra skills here, I'm going to subtract the 272, subtract the 272. I end up getting 88. So 11x equals 88. Dividing both sides by 11 gives me x of 8. And that's what it asked me for. It said to solve for x, so I don't need to go back and plug this in. Now, it says find the measure of each angle indicated in this picture as well. Well, all I know is I've got a quadrilateral, and I know that the angles in a quadrilateral add up to 360. So again, I'm going to take the 82 in the top left, the 105 in there at angle E, the 10x down at angle F, and the 8x plus 11 down at angle G. I'm going to have it have a sum of 360 degrees. I'm going to combine my like terms. I've got some loners here, some loners here, some loners here. So I take all my non-x terms and I add them all up for a grand total of 198. Then I've also got 18 x's. 10 x's and 8 x's give me 18 x's. Make sure you don't say it's 18x squared. I remove the 198. 360 minus 198 gives me 162. So I have 18x is equal to 162. I divide both sides by 18. And I get x being a nice 9. But it didn't say what is x, so let's go back. It says find the measure of angle F. So the measure of angle F is equal to 10 times the x, which is, in this case, 90 degrees. And I'm done. And last step, and we're covering 3 sections today, some properties of parallelograms. What I want you to do is go off onto the side over here, draw yourself a nice beautiful parallelogram, and let's talk about some properties with its sides and angles and diagonals and all that good stuff. So the formal definition of a parallelogram is it has 2 pairs of parallel sides, unlike the trapezoid that just has 1 pair. Now, once I have a parallelogram, there's other stuff that's true. First of all, opposite angles will always be congruent. Next up, although I know that these ones with double arcs are congruent, I actually know what they are because another thing says that consecutive angles, these ones next to each other, are supplementary or they add up to 180. So if those two add up to 180, then this one's actually 180 minus x and 180 minus x. So opposite angles are congruent and neighboring angles add up to 180. And stop for a minute because I think with variables sometimes that's hard to get an idea what I'm saying. If this is 40, I know this is 40. These two have to add up to 180. So 180 minus 40 goes here and right here. So that's the relationship with the angles in a parallelogram. Also for a parallelogram, opposite sides are congruent. I'm going to indicate that with single dashes. What that means is if this is 8, this is 8. Likewise, these are congruent but not necessarily the same as the other two. So this could be 7, but then this is 7. It's easier to see it with the numbers. So in a parallelogram, opposite angles are congruent, consecutive angles add up to 180, opposite sides are congruent, and last but not least, the diagonals, although you can see that they're not the same length, what they do is they bisect each other. And again, we've talked about that word. That means to cut in half. So if I go draw the diagonals over here, and again, put these pictures on here because you can use it for your test. If this is 5, then this is 5. And if this is 10, then this is 10, because bisect means to cut in half or to cut in 2 equal pieces. So we're going to take these properties of a parallelogram and apply them to find missing sides, angles, and diagonals. So let's go up and find angle question mark. This is 70. This is 180 minus 70, or 110. So angle question mark's measure is 110 degrees. So that one was easy peasy, right? Next up, turn the page. What's the opposite side? Opposite sides on a parallelogram are congruent. So question mark is 12.6. Is it always that easy? No, but sometimes. So on the next one, what's question mark? Well, I know this is 55 and this is 55. I told you that the neighboring angles add up to 180. So that angle in there at angle D, the one being cut in half, is going to equal 125 degrees. Well, I've already used up 62 degrees in the bottom left part of it right here. So I'm going to take 125, and again, I know that's 125 because the neighboring angles have to add up to 180. So I'm going to take 125 and remove the 62 that's in there. And what that gives me is 53. Oh, silly. I can't do arithmetic. Sorry, I didn't need to borrow. 63 degrees for question mark. So measure angle. Let's give it a name. It needs to have 3 letters as discussed in a previous section because angle D is actually shared. So I'm going to call it angle B, D, C. And that'll give me question mark. And we just said that that's 63 degrees. And I'm done. And we have 2 more left, and then you can go work on a worksheet. So solve for x. Where is x? It's in at angles. They are neighboring angles. Again, the angles across from each other you set equal. Neighboring angles in a parallelogram add up to 180 degrees. So I'm going to say up at angle U plus up at angle V has a sum of 180 degrees. I'm going to combine like terms. I've got 30 loners. I have 9 x's and 6 more x's for 15 x's. Need to isolate my variable by getting rid of what's in the way by doing the opposite operation. Opposite operation of 15 times x is division. We do that so these cancel. 150 divided by 15 is 10. And did it ask me for x or did it ask me for an angle measure? And again, up here it said solve for x, so I am done. And the very last one, let's go see if we can figure out what this one's saying. KU. Notice there's no bar over that. Remember, we've talked about how when it's like that, it means it's length. So from K to U is 3x plus 3. I'm going to put a little red dot on there. And from U to M, I'm going to put a little blue dot on there, is 4x minus 4. What did I tell you about the diagonals on a parallelogram? I said they bisect each other, meaning they get cut into 2 equal pieces. So this is equal to this. So I know that 3x plus 3, KU, has to be equal to 4x minus 4 for the diagonals to bisect each other. I'm going to get my variable on one side. I'm going to get 3 is equal to 1x, or just x, minus 4. I'm going to add 4 to both sides, giving me an x of 7. And it said to solve for x, so I'm done. So that's it for this one. Your worksheet is 4, 1, 4, 2, 4, 3. And I'm going to say do the evens on this one. Benefits of watching the video. You don't go in and do all of them. It ends up taking you way longer. So have a good one. Peace out, Girl Scout.